Hello students. So we have learned about differentiability. Okay. So let's start with exercise 5.2. So first question is differentiate the function with respect to x. So the function is given sine x square plus 5. So this is your y, right? So dy by dx. Now this is composite function, right? So first you have to differentiate sine. What is the derivative of sine? Cos. Angle remains same. Then applying the chain rule, you will get for composition of functions. Okay, composite functions you have to use. First you have to differentiate this and then the other function which is inside that function. Okay, x square plus 5. So the derivative of x square plus 5 is derivative of x square is 2x and 5 is 0. So the final answer is 2x cos x square plus 5. Okay. Yeah. So second, it is differentiate the function with respect to x cos sine of x. The same way you have to differentiate. So dy by dx is first you have to differentiate cos, which is minus sine, and then sine of x. So this is cos of x. Okay. Next question. Again, differentiating sine first, and then ax plus b, it is a. Okay. So a cos ax plus b. Fourth question is equal to sec tan of root x. So this is your first function, second and third. So dy by dx, differentiate first function which is sec. So this is sec of x into tan of x, derivative. Sec of x is this, tan of root x. Then into tan of root of x into then derivative of tan of root of x. Tan is sec square derivative and then the derivative of root of x, which is root x is x raised to half, right? So its derivative is half x raised to 1 minus half, that is half minus 1. So it is minus half, and minus half is nothing but 1 upon root x. So this is 1 upon 2 root x. Okay. Next question. So sine ax plus b upon cos cx plus d. So here you have to use u by v rule. Okay. So u by v, it's u dash v minus v dash u upon v square. So you can write first, you can find out first u dash, v dash and then substitute here. Okay. So I'll do it this way. So u is sine ax plus b. Okay. So u dash is cos ax plus b into this a. Okay. What about v? V is cos cx plus t. So v dash is minus sine cx plus t into derivative of cx plus t is c. Okay. Now I will substitute it here. So u dash is cos a cos ax plus b into v is cos cx plus d, okay, minus v dash. minus sine cx plus d into u. U is sine ax plus b upon v square. V is cos cx plus d the whole square. Okay. So this is the final answer. Okay. Next question. So here we have u into v. Okay. So u dash v plus v dash u. So find out u dash first. Cos x cube. Now here it is not cos x the whole cube. Okay. This is different and this is different. This cube is for this function x. Okay. So the derivative is minus sine x cube into derivative of x cube, that is 3x. Okay, so we'll get minus 3x sine x cube. Okay. What about v dash? V dash it is sine square x raised to 5. So here sine square is given. Whenever we have x square, we write derivative as 2x, right? So same way you have to write. So first you have to write 2 sine x raised to 5, okay, into derivative of sine, which is cos. Cos x raised to 5 into derivative of x raised to 5, 5x raised to 4. Okay, so now using dy by dx, that is u dash v plus v dash u. Okay, u dash is minus sine minus 3x sine x cube into v. V is sine square x raised to 5, okay, plus v dash. V dash is 2. I'll write this first. 2 into 5 is 10. 10 x raised to 4 sine x raised to 5 into cos x raised to 5 into v dash u. U is cos x cube. Okay. Next question. So 2 is constant. This root is, we can write cot x square raised to half. Okay. So dy by dx is 2 constant. Then you have to use this half cot x square raised to half minus 1, correct, into a derivative of cot. Derivative of cot is minus cos x square, okay, into derivative of x square, which is 2x. Okay. So 2 gets cancelled. This is half minus 1 means minus half, so it comes in the denominator, root cot x square, okay, into, this is minus 1 upon sine square x square into 2x. Okay. Yeah, cot x square. You can cut this. You can make this cot as sine. You can write this as cot as cos upon sine. So this will be sine x square upon cos x square. So in place of cot you are putting cos upon sine. It is in the denominator. So after that substitution, you can take the sine in the numerator. And this is minus 1 upon sine square x square, okay, into 2x. Now how to cut this sine square x square? You can sine x square We can keep the answer up to here also, or we can simplify it. Okay. So how you write root 2? Root 2 I can convert it to 2 by multiplying by root 2 upon root 2, right? So 2 upon root 2. So here also you can do the same thing, that is root sine x square you have to multiply and divide. Okay. So I can multiply root sine x square upon root sine x square. So this root sine x square and this root sine x square root gets cancelled. You will get 1 sine x square, and that gets cancelled with one of the sine x square. Okay. Yeah. Now this is root sine x square and this is cos x square. So you can write them together. So it will be minus 2x upon root, this is just sine x square. Then under root it is cos x square into sine x square. Okay. So again this you can write it as sine x into cos x. So if I multiply here um, root 2 and root 2, okay, then I'll get minus 2 root 2x upon, I'm just simplifying it. Okay. So here it will be 2 sine x square into cos x square. Okay. So this is 2 sine x into cos x, which is sine 2x square. Okay. Next question. Is equal to cos root of x. Okay. So dy by dx. First you have to differentiate cos. So minus sine into differentiation of root x. Root x you know that is x raised to half. So the derivative of this is 1 upon 2 root x. Correct? So the final answer is minus sine root x upon 2 root x. Okay. Question 9 is prove that the function f given by f of x equal to mod of x minus 1 where x belongs to R is not differentiable at x equal to 1. So the function is given f of x equal to mod of x minus 1. Okay. Now here the mod function is given and we know that mod of x is not differentiable at 0, right? So you have to check for the left hand limit and the right hand, that is left hand derivative and right hand derivative. Okay. So at x equal to 1, first you write left hand derivative limit as h tending to 0 minus, okay, it is f of c plus h minus f of c upon h. Limit as h tends to 0 of 1 plus h minus f of 1 upon h. So this is f of 1 plus h, here you have to put. So in place of x it is 1 plus h, 1 1 minus 1. So this is 0 and mod of h. Now here mod of h will be, it is from the left hand side. So the answer will be minus, and minus it is, right? Minus h upon h. So this is minus 1. Same way you have to check for the right hand derivative, that is here it will be plus, and this h, okay, you will get positive h, so you will get plus 1. Okay? So left hand and right hand, they are not equal. Okay, so f is not differentiable at x equal to 1. Okay, question 10, prove that the greatest integer function, okay, f of x equal to box x 0 is less than x is less than 3 is not differentiable at x equal to 1 and x equal to 2. Okay, so first you have to take x equal to 1. Again you have to check for the left hand derivative and right hand derivative. So left hand limit is h tending to 0 minus f of 1 plus h minus f of 1 upon h. Okay, we are approaching from the left hand side. So 1 f of 1 plus h, you can write limit as h tending to 0 minus box 1 plus h minus 1 upon h. Okay, so this is 1 plus h, right? We are approaching from the left hand side. For a greatest integer function, this answer will be 0, correct? X is between 0 and 3, and we take only the integers, right? So this answer will be 0. Okay. If it was, we were approaching from the right hand side of 0, then it would have been 1. Okay, so this is 0 minus 1 upon h. Okay, so h is 0, so this becomes infinity. Okay, for right hand derivative h tending to 0 plus, okay, f of 1 plus h is 1 plus h minus 1 upon h. Now this answer is 1 plus h box. This will be 1 minus 1 upon h. So this is 0. Okay. So they are not equal. So we can say that f is not differentiable at x equal to 1. Now we have to check for differentiability as x equal to 2. Same way you have to proceed. Okay. So left hand derivative limit as h tending to 0 minus. Now your x is 2. So this is 2 plus h minus f of 2, which is 2. Okay, upon h. Now we are approaching from the left hand side. So it is 0, x is between 0 and 3. So left hand side, so less than 2 you have to take, that is 1. Okay, so 1 minus 2 upon h. Again this is infinity because h becomes 0. For right hand side it is, now this you have to take 2, right? So this is 0. Again, it is not differentiable as left hand derivative is not equal to right hand derivative. Okay. Next, we can solve exercise 5.3. Okay. So first question, you have to find dy by dx and the function is given. This is implicit function sin x. So find out derivative directly. Derivative of x is 1. Derivative of y, here single y is there. So it is dy by dx and sin x is cos x. So your dy by dx is cos x minus 2 upon 3. Okay. Next question. So this is 2 into 1. 3 dy by dx and here it is cos y into dy by dx. So dy by dx terms you take together. So dy by dx you can write outside 3 minus cos y. I'm taking this whole term here. Okay. And this term I'm taking that side. So dy by dx is minus 2 upon 3 minus cos y. Okay. Next is this. So this is a into 1. Then b is constant. Y square you can write 2y dy by dx. And cos y is minus sin y into dy by dx. So again taking dy by dx terms together, 2by plus sin y equal to minus a. So dy by dx is minus a upon 2by plus sin y. Okay. Next question. So here this is uv. Okay. So first you differentiate x1 into y plus x you have to keep as it is and differentiation of y is dy by dx. Then this is 2y dy by dx. Every time wherever there is y you have to write dy by dx. Derivative of 10 plus dy by dx. Now again take dy by dx terms together. So it is x plus 2y minus 1 equal to sec square x minus y. Okay. So dy by dx is equal to sec square x minus y upon x plus 2y minus 1. Okay. Next question, square plus xy plus y square equal to 100. So this is 2x plus here uv rule 1 into y plus x into dy by dx plus 2y dy by dx equal to, this is constant, so 0. Okay. Taking dy by dx terms together, x plus 2y. This terms I'm taking that side, so it is minus 2x minus y. So dy by dx is minus, I'll keep outside, upon x plus 2y. Okay. Sixth question, x cube plus x square y plus xy square plus y cube is equal to 81. Okay. So this is 3x square plus uv rule 2x into y plus x square into dy by dx. Again uv rule 1 into y square plus x into 2y into dy by dx plus 3y square into dy by dx equal to 0. Okay. taking dy by dx terms together, x square plus 2xy plus 3y square equal to, other terms I'm taking that side, so minus 3x square minus 2xy minus y square. Okay. So dy by dx is minus 3x square plus 2xy plus y square upon x square plus 2xy plus 3y square. Okay. Next question. Sin square y plus cos xy equal to pi. Sin square y is 2 sin y into, then sin of y derivative you have to write, that is cos y into derivative of y dy by dx plus, okay, cos xy. So this is minus sin xy and then the derivative of xy. Here you have to use UV rule. So 1 into y plus x into dy by dx equal to 0. Okay. So taking dy by dx terms together, first you have to multiply this inside. So I'll write 2 sin y and this term minus sin xy y. Okay. Then this term I'll write dy by dx outside, cos y, then this into this, so it is minus x sin xy equal to 0. So dy by dx is 2 sin y minus y sin xy upon cos y minus x sin xy. Okay, let's solve this. So again we have to use 2 sin x into derivative of sin x cos x plus 2 cos y into derivative of cos y minus sin y and then derivative of y equal to 0. So here only one dy by dx is there. So dy by dx is minus 2 sin x into cos x upon 2 cos y into sin y. So you can use the identity and write this as minus sin 2x upon sin 2y. Okay. Minus, and this is also minus is there. No? So this minus gets cancelled.